Welcome to Team Apex Finesse. Today I want to talk to you about the 4 stages of a naturally aspirated engine cycle. You have intake, compression, power, exhaust. Starting off with stage 1, which is the intake stroke. At this stage, the piston travels downwards in the cylinder. Because of the downwards movement of the piston, it creates a partial vacuum because the inlet valve is open. Now that partial vacuum draws in air via the intake manifold. At the same time, a precisely metered amount of fuel is injected into the cylinder. Now, there is a specific ratio that is known as the optimum environment ratio for engine combustion, and that is 14.7 to 1. That's 14.7 parts of air to 1 part of fuel. And that could be in grams, in ounces, it will always be the same. 14.7 parts of air to 1 part of fuel. Now, this ratio right there is called the stoichiometric ratio. It's called stoichiometry when you're talking about engine ratios. And it can vary depending on the temperature of the engine, cold start if the car's hot, the load on the engine, and also the RPM. So the ratio can vary. Stage 2 is the compression stroke. Now at the end of the intake stroke, the piston reaches the bottom of the cylinder. This is known as BDC. That is where the intake stroke is finished. Now at this stage, the inlet valve is closed and also the exhaust valve is closed. So the piston travels upwards in the cylinder due to the rotation of the crank. As the piston travels upwards, that volatile mixture of air and fuel inside the chamber is getting compressed into a smaller space. This increases pressure and it also increases the density of that mixture. On the compression stroke, as the piston reaches the top, which is known as top dead center, TDC, the compression stroke is complete. Now we move on to the power stroke. Via the ECU, a spark is created via the spark plug. Now we are talking a petrol engine, we're not talking diesel engine, because that's a whole different ball game. That works purely on compression. They don't have a spark plug. They only have a glow plug, which is just to heat the engine up. So via the ECU, that spark is created. Now we call that ignition. We don't call it an explosion or anything else, because ignition is a controlled event, and that's exactly what this is. It's precisely engineered to the point where it's controlled at the end of the day. That's what I'm trying to say. It's controlled. So because of that spark that's been created, that ignition right there creates a rise in pressure, a rise in heat, which acts on all different angles. The only place that it can go is downwards. Most importantly, downwards on the piston face. On the piston face. Can you see that? On the piston face. Now that pressure acting downwards on the piston face, once that ignition is created, the pressure rise and the heat rise is accomplished. That energy is going to push downwards on the piston face. This is the power stroke. This is how we create power. This is the 3rd stroke of the 4-stroke engine cycle. On the power stroke, all that force acting upon the piston surface, the piston face, pushes that piston down, which is connected to a connecting rod, which is then connected to the crank. That crank is turning. What do we have here? We've created torque from creating power. So the more power you can create, the more torque you can create. Let's not get into that. Once the piston has been forced down, it is at bottom dead center for the 2nd time in the 4-stroke cycle. Now it's time for the piston to travel upwards. As the piston travels upwards, due to the rotation of the crank, because of the torque that we've created from all that power, the piston moves upwards and expels all of that waste, we'll call it waste for now, all of that waste gas out the exhaust valve, into the exhaust manifold, through the downpipe, through the exhaust system. That, my friends, brothers, sisters, queens, kings, princes, princesses, is the 4-stroke engine cycle.